Okay, so here's a second example. This one we're going to focus on a confidence interval. So a company has set a goal of developing a battery that lasts over 5 hours in continuous use. And so there's the first 12 batteries. We're not going to do A because A is, go away cat, because A is another hypothesis test and we don't need to do that process again. What we are going to do is we are going to do parts B and part C. Part B is a confidence interval. And remember, still when you do confidence interval, you still must check conditions. Okay, so we're going to say this is B. So we're going to start by checking our conditions. Okay, so it says the first test of 12 of these batteries. So it doesn't say random. We're going to assume 12 batteries were randomly selected. Because I'm sure they did not just produce 12 batteries. I'm sure they produced a lot more. Okay. 12 batteries is less than 10% of all produced. And if you want, if it makes you feel a little better, you can also assume 12 batteries is less than 10% of all produced. What's the next one? Independent. Okay, so lifespan of battery is independent. And the last one, we have to look at the histogram, right? And because this is a pretty small sample, it needs to look roughly unimodal and symmetric. So first thing you got to do is enter all your numbers in your calculator, which I've done already for us. Once you're ready, we're going to graph it. So we got to go second, y equals. Now, we already graphed the last problem, so it says plot 1 is on, and it's a histogram. So we're ready to graph. And remember, you may not see it, so you have to hit zoom and then go down and choose number 9 to make it a stat window. Okay, it doesn't look great, but that is roughly unimodal and symmetric. So that's close enough. It's not skewed, we don't have outliers. So histogram is roughly unimodal and symmetric. Okay, so now I'm going to change colors for each part I do. So now what we're going to do is we're going to run a 1 sample t interval with our degrees of freedom being 11. Okay, so we do need to find out what our mean is, and we do need to figure out what our standard deviation is. So we need to find our mean, which we'll get off our 1 vars, and we need to find our standard error, which we have to find out the SX, and then we take the square root of 12. Okay, so let's run our 1 vars. So stat calc 1 vars. And so we get 306.25 and 29.3. Okay, so 306.25 and then 29.3. Okay, so now I need to do this part to find out what the standard error is for the sample. So 29.3 divided by the square root of 12. So 8.46, we'll say that. So that's pretty good. Okay, so that kind of gives us our parameters. It tells us what we're doing. Now we have to do the math. Now up here, I just want to remember, I'm going to use this rainbow pen. I like this one. So remember you have to find your margin of error, which is your mean plus or minus your critical t times your standard error. Isn't that cool? Okay, so we know what this is. We know what this is. We have to find that. And so remember, this is where we would draw our picture If 90% is in the middle, what's right here? And so that's a 0.05. So now we need to do our inverse t. Okay, so we're going to go second vars inverse t. The area to the left was 0.05. And then our degrees of freedom is 11. So remember when we were doing 95 percentiles and it was always 1.96? Because degrees of freedom is what controls kind of what percentiles are, you're never going to be able to memorize them for this one because they're always going to change based on what the degrees of freedom is. And so this one is negative 1.795. So we can round that up to negative 1.8. So the t-score, or not the t-score, but the critical t, I'll make that back to blue. The critical t is negative 1. What did I say? I already forgot. 1.8. Okay, so now we're going to take, let's highlight a different color. Let's take our information. We need our mean. We need our t. And we need our standard error. And we're going to plug it in. Okay, so it'll be 306.25 plus or minus negative, well, you could say negative 1.8, but a plus or minus is going to make the negative go away. So 1.8 times 8.46. So usually I do the minus one first because you want your smaller number first. So this is going to be 291.03 and then 321.47. Now I'm looking at my old notes. Let's see if it actually is that amount. Yeah, so it's pretty much the same. I think maybe when I did the notes last time we did something else. But okay, so now we have our confidence interval. Now we need to interpret it. So last color, let's go to black. So we are 90% confident that the average, because mean is average, battery life is between 291.03 and 321.47 minutes. Now, if we wanted to run a full hypothesis test, what do you think our result would be? Do you think that we would be rejecting, or do you think that we would be failing to reject? Well, if you notice, it's saying that they want it to be more than 300. But you see how 300 is actually inside that interval? So because that range of numbers includes 300, there's not going to be enough evidence. We would fail to reject that. Okay. All right. So now let's look at part C. I think I'm gonna copy part C and put it down here. Hold on a second. Okay, at this point, part C, when I look at it now, this would not be a problem that I'm going to give regular stats. I might do it if it was a regular situation with school, but because of everything going on, I think this will just be finding the sample size is just going to be something I do with my AP students. So regular stats, you're done. You can just finish through here, and that's it. Okay, so AP stats. Here's the thing. We're going to do this within 15 minutes. So we'll do this one. Margin of error is 15. And then the margin of error is 5. Okay, so I know that you know how to set this up. 15 equals, it's going to equal the critical T. What was it? 29.3, because that's the mean, divided by square root of n. So now here's the issue that we're going to have, is that a 95 percentile, it changes, the critical T will change based on the sample size, but we don't know the sample size. So what we do is we start off by using the 1.96 because that's what we know it is for a Z, okay? And then what we're going to do is once we figure out what it is there, we're going to have a closer estimate of what the size of the sample needs to be, and then we'll find the critical T. So for this, what you do is you start with a critical Z. even though we're doing a t-test. Okay, so we're going to solve that problem by multiplying out, and so I'll get 15 times the square root of n is equal to, let's see, 1.96 times 29.3, 57.428. And then you're going to divide by 15 and square it. This is the only one I'm going to show all the work on. And so divide by 15 and square it. And so that gives me approximately 15. So instead of an equal sign, let's make it approximately 15. So now what happens is we go back and do it knowing this, and so we can actually find a critical t. Okay, so it'll be, let's do purple. Oh, we just did purple. Let's try a different color. Orange. So 15 is equal to, now let's go find out what our critical t is for this. So we're going to go second vars inverse t. To the left is 0.025. And our degrees of freedom is 14 because it's the sample we saw minus 1. And it's going to give us a little bit different of a value. And so we're going to do 2.14 times 29.3 over square root of n. What this did was this first step right here, that first step up above, kind of let us get an estimate of how big the sample is. And then what the second step is going to do, it's going to kind of let us hone in on what it actually is. And so now I'm going to do 2.14 times 29.3 divided by 15. And then I'm going to square it. And so it's 17.47. So we're going to say that sample is 18. So it didn't change it that much, but it did get it a little bigger. Okay. All right. What I'd like you guys to do is try this same process for a margin of error of 5 and see how you do. Okay. So you start off with your critical Z of 1.96, and you should get about a 132 as a sample size. So that's the estimate. Now we're going to find the actual critical T of that. So inverse T, still 0.025. What did we say it was? I already forgot. 132. So then my degrees of freedom is 131. Paste. And so now that's going to be pretty close to 196 because 1.96. Because remember, the bigger the sample, the closer it is to normal. So we'll say this is 1.98. 1.98 times 29.3 divided by square root of n. Okay, and so 1.98. Oops, wrong thing. Okay, so 1.98 times 29.3 divided by 5, and then square it. And so it gets us a little bit bigger, so 135. So our n is about 135. Okay. All right, hopefully that makes sense. Pop into tutoring times if you have questions.